All right, example 3, the final example for now. Which table represents linear functions? Okay, so in order for a table to represent a linear function, it must have a constant rate of change. So what we're going to do, so looking at this first table, what we're going to do, make sure you copy these 3 tables down before we start. Good. We're going to check that there's a constant rate of change in the table. So here's what we're going to do, okay? I'm going to branch out and make an extra column and put this. This is delta x, which means change in x. Branch out here, delta y, and then one more, which is delta y over delta x. Okay, so bear with me. All right, so if we look at the change in the x's, so in other words, what's the change from 1 to 7? Well, if you look at the change from 1 to 7, it's 6. The change from 7 to 10 is 3. The change from 10 to 19 is 9. In other words, in order to get from 1 to 7, you have to add 6. To get from 7 to 10, you have to add 3. To get from 10 to 19, you have to add 9. All right, now let's look at the change in y. So from negative 6 to negative 10, we are subtracting 4. To get from negative 10 to negative 12, we're subtracting 2. And to get from negative 12 to negative 18, we're subtracting 6. All right, so in other words, now the change in y, we're changing x, where it's going to take change y, we're changing x. So that's negative 4 over 6. Here it's negative 2 over 3. And here it's negative 6 over 9. And then we're going to simplify the fraction. So negative 4 over 6 simplifies to negative 2/3. Negative 2/3 simplifies to negative 2/3. And negative 6 over 9 simplifies to negative 2/3. So guess what? This and this and this are all equal. So therefore, this has a constant rate of change. So this one is linear. All right, now let's do the same thing for this table. We're going to change in x. We're going to do change in y, and then we're going to do change y for change of x. That's a little triangle. That means delta, by the way. Delta y over delta x. Delta x is a Greek letter. Just for your info. So let's do this. So change in x. So negative 3 to 1. That is a jump of 4. 1 to 3 is a jump of 2. 3 to 5 is a jump of 2. 10 to 16 is a jump of 6. 16 to 18 is a jump of 2. 18 to 22 is a jump of 4. So we have 6 over 4, 2 over 2, and 4 over 2. So this simplifies to 3 over 2. This simplifies to 1, and this simplifies to 2. So these are not equal. So this is not a constant rate of change. Making this non-linear. Last table. Change x. Let's do a little divider here so that we don't get all the problems confused. Change in x. change y, delta y over delta x. We got minus 3, minus 6, minus 6. And we've got plus 5, plus 10, plus 10. So 5 over negative 3, 10 over negative 6, and 10 over negative 6. 5 over negative 3 is just negative 3/5. 10 over negative 6 equals negative 3/5. 10 over negative 6 equals negative 3/5. So negative 3/5, negative 3/5, negative 3/5. Constant rates of change. Therefore, it is linear. So linear, nonlinear, linear. Thanks.